All right, so yesterday we focused on prisms for the most part. We did have a cylinder problem in there as well. Today we're going to focus more on cylinders and spheres for worksheet 2. So this is actually at the bottom of page 4. I covered it up, but we did the top of this page already, and we're just doing the bottom of page 4. That's the only examples we have, so your notes should be pretty short today. So determine the volume of the cylinder, sphere, or irregular figure. So volume of a cylinder is going to be area of a triangle, so pi r squared times the height of the prism. For a sphere, it has its own special formula, which is also on your title page for this section, where you have 4/3 pi r cubed. So here, just for this regular sphere, I mean, it is kind of tilted, but we did learn in Cavalieri's principle yesterday that doesn't make a big difference because it's just like we took, let's say, like a stack of quarters and they're slightly tipped over. They still have the same volume as if they were upright. So I'll have my pi 5 squared times 9, and we'll go ahead and leave this in exact form. So we'll have 25 times 9 gives us 225 pi cubic centimeters. Volume's always in cubic units. Here I have a hollow cylinder where this is a hole, so we're going to do the big one minus the small one. That'll be the easiest. So for our larger cylinder, our radius should be 2.5 since the diameter is 5. So 2.5 squared times 8 is 50 pi. And then our smaller cylinder on the inside has a radius of 2, which should give us 32 pi. So if I take 50 pi minus 32 pi, I end up with 18 pi cubic centimeters. All right, C. If you are looking at it too quickly, you might think it is half of a cylinder, but really here, our half of our cylinder would be about there. So you have a cylinder on top of a rectangular prism in reality. And I know that this radius is going to be 3 because all the way across is 6. So I have a rectangular prism on the bottom where I have 2 times 6 times 10 to get that volume. And then I'm going to add my half cylinder. So half of pi r squared times height. So 2, 6, and 10 should give us 120. And then this should give us 9 times 5 is 45 pi. And if I want exact form, I would go ahead and leave it like this. I can't combine it any further. Cubic centimeters. All right, for letter D here, I have half of a sphere. So if my volume formula is 4/3 pi r cubed, I'm going to do 1/2 times 4/3 pi r cubed. So I know that my radius, if the diameter is 12.8, my radius is 6.4. And we'll go ahead and do rounded form since our radius was a decimal. So our rounded form would be 549.03 cubic meters. So we like to do exact form when we can. With decimals, it makes it a lot harder, so we'll do rounded form there. Letter E says a sphere has a volume of 9/16 pi cubic inches. Find the radius. So this is our volume. We'll set it equal to our 4/3 pi r cubed. So right away, since there's a pi on both sides, we can get rid of those. And then to get rid of 4/3, I'll multiply by the reciprocal of 3/4. So then we have 27 over 64 equals r to the 3rd power. And then we'll have to cube root to get rid of that exponent of 3. So the cube root of 27 is 3. The cube root of 64 is 4. So we have 3/4 inches for our final answer here. All right, that's it for today's notes. You should now be working on worksheet 2.